Good morning, everybody. My name is Karina Orquera. I am a PhD student at CITA Research Center in Spain. The title of this presentation is The Effect of Routine Practices on the Behavior of Beef Cows According to Their Feeding Management. The current study is a collaboration between Spanish CITA team and the French INRAE team within the GenTORE project. Introduction. Ruminant production systems are increasingly subjected to changing environments. To cope with these disturbances, it is necessary to select robust and efficient animals in terms of conversion of available resources into milk and meat products. In the particular case of beef cows, their ability to face variable nutritional environments, robustness, involves adaptive processes that drive adjustment in their energy allocation toward the different life functions. This ability to cope with nutritional challenges involves physiological adaptation, which can be expressed through different behavior patterns. In recent years, multiple devices have been used in dairy and beef cattle studies in order to monitor physiological and behavioral parameters. Their accuracy to measure behavior and identify between cow variation is variable and may depend on the experimental design and the feeding and general animal management. As part of a larger study aiming to analyze the components of feed efficiency and resilience of beef cows, this experiment focused on the effect of routine weighing of beef cows on their behavior patterns, and if this effect depends on the feeding level. Materials and methods. The experiment was carried out at the Lacoy Experimental Farm in Aragón in France. We used information of 12 years old Charolais beef cows that had calved in late February and were in the second month of lactation. They were fed a diet composed of hay and concentrate, the composition of which is presented on the slide. The diet had been formulated with intra-ration software to meet the individual feed requirements according to the cow weight and milk yield. The daily diet was offered individually at 8 in the morning in individual throws with automatic gates. From the second month of lactation, the cows underwent 5 nutritional challenges during periods of different length. Only periods 2, 4, and 5 were used in the current study. Basically, in these 5 periods, the feeding management was different during challenge and recovery phase. The challenge consisted of a feed restriction where only 50% of the requirements were administered during periods that lasted for 4 to 10 days. Thereafter, in the recovery phase, cows were fed a diet that met 100% of their needs again. During both the challenge and recovery phase, there was also a different weighing management. On some days, the cows were moved from their pens and weighed at 1.5. BW is days with body weight measurements, but others days no. W0 is days without body weight measurements. Therefore, we had 3 periods, 2, 4, and 5, 2 feeding management, challenge and recovery, and 2 weighing management, days with body weight measurements and days without body weight measurements. Continue with materials and methods. All cows were equipped with a collar continuously recording animal activity via media axle accelerometer sensor and data logger. For each 5 minutes periods, only the single most dominant activity was selected among the 5 recorded. Finally, each day included 288 periods of 5 minutes for 24 hours per cow. So, the database was with more than 100,000 data. The raw dataset was accessed online and provided information on 5 different activities. These activities are ingestion, rumination, rest, overactivity, and other activity. Overactivity is related to the heat and excess activity behaviors, while other activity is unidentified behaviors not associated with the other 4 activities. For statistical analysis, we use a linear mixed model by our program. We analyzed the daily time dedicated to each activity over 34 days, equally distributed among treatments. As fixed effects are feeding management, challenge versus recovery, weighing management, body weight versus without body weight days, and periods 2, 4, and 5, which go as the random effect. Next, I am going to present the results. In this figure, we can observe globally the time budget devoted to each activity, expressed in minutes per day and in percentage too. The single most important activity was resting, and is followed by rumination, then by other unidentified activity like suckling their cats or being idle. Next was ingestion, and finally overactivity, which is related to height movements, particularly around the heat. From here on, we will present the time devoted to each activity according to the interaction between feeding and weighing management, which was significant for most activities. We will not present the effect of the period because it was not significant except for rest and other activities. So, the first activity is ingestion. We found an interaction between weighing and feeding management. During the challenge phase, ingestion time was shorter in body weight days than without body weight days, but we found no differences associated to weight management during the recovery phase when animals were fed at 100% of the diet. Next activity is rumination. We also found an interaction between weighing and feeding management. In the figure, shorter rumination time in body weight than without body weight days during challenge, but not differences during the recovery, with similar rumination time irrespective of weighing management. The rumination time was longer in recovery phase, associated to processing the larger amount of the diet consumed. From the intake and rumination activity, we can say that moving the cows from their pens to a scale and back had a clear effect both on intake and rumination, when fed was restricted to 50%, not when it was provided meet 100% of their requirements. During the challenge phase, on these weighing days, cows seems to speed up both eating and ruminating, as compared to the days without body weight measurements. The next activity is rest. We also found an interaction between weighing and feeding management. As we can see, resting time was longer in body weight days than without body weight days during challenge, but no differences were observed during the recovery phase, when the time spent resting was equal for both weighing managements. Besides, the shorter time devoted to rumination in the challenge phase was reflected in longer resting time under this feeding management. Next is overactivity. We didn't find any interaction between weighing and feeding management, so here we will focus on the single effects. Feeding management had a highly significant effect on the time devoted to overactivity, which was shorter in challenge, 93 minutes, than in recovery phase, 135 minutes. And respect to weighing management, it only tended to affect overactivity, with longer time in body weight days with 121 minutes than without body weight days with 107 minutes, which would be logical since this activity reflects extra movements. And finally, other activity. We found again an interaction between weighing and feeding management, with slight differences between periods. As we can see in the figure, the time dedicated to other activity was longer in body weight days than without body weight days during challenge, but not during the recovery. On body weight days during the challenge phase, the time saved from faster eating and rumination was spent in longer resting and other activity as compared to the days without weighing. Conclusions. From this study, we can conclude weighing around midday interfered mostly with the time spent by cows eating, ruminating, and resting, but only when feed intake was restricted. The effects of both factors on overactivity and overactivity were less evident. These findings should be taken into account in order to schedule routine management to avoid and/or minimize interference with cattle natural behavior patterns. Thank you very much for your attention.